Hi everyone, welcome to the November edition of CyberSciBar. And in fact, this is going to be the final CyberSciBar of 2020. We tend to avoid doing one in December because we really take that month as a bit of time to sort of take stock of the year, how we've done, in the hope that we'll improve and can come back next year with some even bigger and better speakers and events. So this is exciting. Obviously, you all know 2020 has been a very turbulent year for everyone, Palace of Science included. But to be honest, actually, for us, it's been a really good year. And before we get down to the talk tonight, I actually wanted to take this opportunity to thank a few of the people that are responsible for actually helping make this year a success for Palace of Science. So for many of you, you might not know, this year we became a community interest company, officially registered as a company, a not-for-profit. A huge amount of work went into that. In particular, I'd like to thank Will, Callum and Stacey. They put a lot of effort into it, and it means that hopefully in future we'll be able to secure some funding so that when we can get back to you in person, our events can be even bigger and better. This year we started the Palace of Science YouTube channel as a result of the pandemic. So we were exclusively an in-person events prior to lockdown, and then exclusively all online, which was a huge transition for us. And I'd like to give a really special thanks to Ewan, who helps to organise a lot of this. So he is the technical wizard that organises all the bells and whistles from what you see now. There's a lot of complex stuff that happens. He put the YouTube channel together and makes sure that all of our talks go onto there. And as well as keeping this all running very smoothly, he also reminds me to turn my microphone on every month as well. So he's got a lot to pay attention to. He does a great job. I'd also like to thank David Glass from Skeptics in the Pub. He really helped us out with the transition to online presentations because we had essentially no idea what we were doing at the start. So thank you if he's watching tonight. There's also quite a few other members of Palace of Science, particularly now we are virtual. Obviously, every month you usually see me, but there are many other members in the background that really helped keep things going. We have an awesome annual events team. They planned a great event this year that unfortunately had to be cancelled at the very last minute, and Paul and Stacey in particular. But they put so much effort in, and they are just waiting in the wings to organise an incredible science festival as soon as we allowed to host that. This year, we also lost a communications officer, Amelie. She moved down to London to work in Parliament. Traitor. No, she's doing a great job down there. But in her stead, we gained some new members, and they're all settling in very nicely into their new roles and helping us out a lot. So thank you to them. I also need to thank, obviously, all of the speakers that have taken part in CyberSciBar, particularly since April. All of our speakers have presented online. They've been happy to do so. And importantly, they've all very kindly allowed us to record their talks. So you can catch up on all of the events we've held since April on the Palace of Science YouTube channel. And there's a huge variety of stuff to see there. The mathematics and magic, antibiotic resistance, the culture of there's all sorts of stuff, so do check that out. And of course, the audience, thank you so much for watching every month or dipping in and out, or if you're new, welcome and thank you. We have to admit, I think generally we do prefer being in person, being able to see all your wonderful faces and seeing your reaction to the events. But obviously going online does have its benefits. We're a bit more accessible, and we've managed to attract people from all over the world, actually, which is really good. So thank you for your support. And of course, if you have any feedback for us about any of our events from this year or tonight's event, we do have a feedback form that you can fill in. That should appear in the chat bar at some point. And if you do fill out a feedback form, we will be picking a lucky winner at random to receive some lottery tickets. So we joined one lottery this year. Our first lottery draw is on the 19th of December. And you could be in with a shot of winning, I think it's £25,000. It's a special lottery platform for not-for-profit organisations. And of course, if you buy a ticket, some of that funding will come back to us and events. The final thing I wanted to say is obviously if you want to know more about what we do, we have a website. You can follow us on social media. We have our YouTube channel, or you can just let us know now. If you want to let us know about anything you're thinking, then please do add any questions or comments to the chat bar, and we have someone monitoring that. So that's everything I wanted to say for now. As always, the talk tonight will be about half an hour long, and then it will be followed by a 5-minute break, so you can all refresh your glasses, get yourself a beverage. And then there will be a question and answer session. So if you do have any questions for our speaker tonight, please put them into the chat box. You need a Twitch account to do so, but it's free and easy to sign up. You've got plenty of time to do that. So without further ado, our speaker tonight is based at Newcastle University in the Department of Business Development and Enterprise. He's slightly different in some of our previous speakers in that his official title is an Innovation Associate, which is a really cool title. Part of the work he does brings together sort of science and business, which I think is an increasingly important area. He's had a very varied background, and if you want to know more about that, you are, of course, welcome to ask him at the question and answer session at the end. But the talk he's going to give us tonight, I think most of us are personally familiar with, certainly in need of that caffeine hit in the morning and throughout the day for many of us. So if you'd all join me in giving a warm virtual welcome to Dr. Chris Howell.
Thank you very much for the introduction, Nicola. So really glad to be here at long last, and really glad to be at a Palace of Science CyberSciBar event. So I'm going to talk tonight about the chemistry of coffee. I think when I first thought about giving this talk, I thought, right, let's try and keep it to chemistry, or maybe try and broaden it out and not keep it so focused on just chemistry. Chemistry is a very scary thing. So I thought we might rename it the science of coffee, and try and broaden people's scope and get more involvement, maybe some biosciences, maybe some engineering, maybe some physics even there of coffee. But when it came down to it, the actual title I did want to give the talk was far too scary. So we decided to push away with that and just stick with the original chemistry of coffee. So I'm going to briefly skim through the topics of the talk. That's the intro. So who am I? Academics love to talk about themselves. I'll give you a bit more about what I do for the university. I'll talk about coffee. Obviously, that's one of the big reasons why we're here. I'll talk about water and how that's important for coffee chemistry and how that affects the drinks that we drink. I'm trying to make it why this kind of science is relevant, and why such a trivial topic as coffee or the science of coffee is actually more important than probably we give it credit. And finally, there will be some tips and tricks about how to make your coffee taste a little better. So if you come away with nothing else from this talk, at least you'll know to give it a bit of an extra stir or a bit more time in the pot and really get the best flavor out of your coffee. So a bit of background about myself. So for the best part of the decade, this was me. Quite happy in the chemistry lab. Please don't look at the open lab coat, but yes, this is where I lived. I spent a lot of my time making plastics or polymers in the chemistry lab, and I would take them to high energy beam lines and analyze them. So this is one in Daresbury between Manchester and Liverpool. There's another beam line down in the southwest called Diamond, and if you're really lucky, you get to go to some really exotic places at the dead of night, like the INL in Grenoble in France, or even CERN in Switzerland, and learn lots about the high energy particle physics that they do there. Like all the speakers that have spoken throughout this year, we are three-dimensional human beings. I'm not just a scientist. I'm not just an innovation associate, as glamorous as that sounds. I also have cats, a life, a partner. I like to go traveling on a motorbike and do that with someone else, someone special in my life. So yeah, we are all fully fledged human beings, as well as being quite devoted to the scientific method. So why coffee? I mean, what is this great interest in coffee? It's not even the world's favorite drink. I mean, I like coffee. I don't have any coffee tattoos, as if Rebecca Owens is watching. But yeah, I mean, I like coffee. But coffee itself is the science of making coffee. It's like a dark art to get the best chemistry and the best chemicals out of your brew. You have to understand like a bit of principles about science. Do you stir? Do you add milk to your coffee? Do you do all these different things to make it taste just so? So yeah, there's a lot of science and understanding about what makes a good cup of coffee. Coffee is also big business. I mean, about 1.8% of the GDP of America, that's about $200 billion is spent on coffee. And that's just the USA. For other countries, it's a large part of their agricultural economy, a huge part of like exports for Central Africa and some of the Central American countries. So it is quite big business. So it's quite important to understand this cash crop. And finally, when we did actually come up with the idea for this talk, it was actually developed at the Tyneside coffee rooms where the CyberSciBar events normally held in person. So I guess I have a lack of imagination on that front and just thought coffee, that'll do. So thinking about coffee around the world and how it's actually developed. So when we think about coffee, we normally think about the traditional Italian espresso. But it's gone global. I mean, this drink has got such a persona about it, and lots of cultures and countries have decided to make it their own. I mean, North America's decided to stick with filter coffee, so they've actually bulked it up with more water and really gone for the caffeine hit. In Nordic countries, they've decided that they can't get enough of a good thing, so decided to mix cheese with coffee. So this is coffee ust. In Valencia, in Spain, they've decided to mix condensed milk with coffee to make a bourbon coffee, so a very sweet tasting kind of drink. In India, they've decided to go for a filter coffee that's kind of poured between two different cups to achieve like a very frothy and foamy head, and that's brewed with hot milk. You've got Arabic coffee, so you've got the Hafwa coffee. It's very finely ground and mixed with interesting spices like cardamom or cinnamon. There's Turkish coffee, which is kind of brewed in a cheve and buried in sand to actually help the grounds kind of agitate from all directions. And lastly, I'll just point on to Vietnamese egg coffee. So this is coffee for people who love eggs, milk, coffee, essentially a cake in a small coffee cup. But it's quite filling and sweet, and it has a nice kind of like warming coffee taste to it. So that's a little bit about coffee and where it's gone around the world. And I hope that gives you a bit of kind of like idea about the cultural significance of this drink. So when it comes to expectations versus reality, I like to think now of an example that's quite topical and close to the news. I know a lot of people have been watching the Bake Off, so I want people to think about something like a cake. So you probably think, right, I've been watching the Bake Off, and boom, I can do one of those at home. I can just go down to the supermarket, get the ingredients, and just whack it all together, and I'll get me a great cake. And when you do exactly that, without any of the knowledge and the skills, or maybe even the equipment, you may think to yourself, right, I can get this right, I can get this just so. But somewhere along the way, it goes very, very wrong. And similarly, something else happens when you do it to coffee. So you can very well buy some fantastic beans, or you can buy some freshly ground coffee pre-packed in a jar. And you think to yourself, right, I'm going to make me a brew. I'm going to make me a fantastic cup of coffee. And you do. And you get some fantastic citrus notes. You get some beautiful berry notes. You even get some nuttiness to the taste, some flavor of your coffee at the end. And you think, wow, that was a fantastic cup of coffee. But the very next day, you might make another cup of coffee and find that everything's all changed. You find that you're pulling some weird kind of like licorice notes or Brussels sprouts kind of tastes out of it. You might have found that you're even getting some kind of mole flavors coming through, which is bizarre. And truly, if you find yourself in this kind of situation with something really unpleasant, obviously making your coffee has obviously gone very wrong somewhere down the line. So it's important that we understand like what kind of factors actually contribute to the flavors in a cup of coffee. So it comes as no surprise that 50% of the coffee flavor comes directly from the bean. I mean, good coffee in the first instance should mean good, freshly ground in your cup. Surprisingly, 20% is to do with the processing. So that's roasting and grinding and storing your coffee. An interesting outcome of this is that 20% of your coffee flavor comes from the water chemistry. So this was quite a surprising find, that actually something quite innocuous can have a very strong impact on the final flavor of your cup. And we all know someone like this who has spent all the money on the gear, who thought to themselves, I'll buy myself a beautiful coffee machine and it'll come out perfect every time. But really, the equipment only counts for really 10% of your final brew. So understanding the kind of roast, your green coffee, and the water chemistry of the area that you live in has a massive impact on the final coffee flavor. So thinking about the green coffee, it's good to understand where coffee comes from and where it's grown and what influences it. So coffee is traditionally grown in environments about 20 degrees north and south of the equator. So particularly Central and South America, the Central African belt, and parts of Southeast Asia. I believe the Philippines is missed off that map, and areas of Cavite are now starting to grow their own coffee. And it's interesting to understand the species that are actually grown in these environments, and what's actually a lot of hard work that actually goes into making these cups. So there's two primary species of coffee. There's actually about 17, but these are the two big ones. So we've got Arabica beans, which are grown at altitude, and they're actually quite difficult to grow. They actually have to be monitored. They have to have like some careful care and attention. They have to be picked. The berries have to be picked at the correct time, and they're quite susceptible to pests, and even some strong herbicides can have devastating effects on the coffee crop. Unfortunately, 70% of the world's coffee is actually Arabica coffee. It supposedly has better flavor. Now, this kind of is a bit of a debate that goes back and forth, but be it what it may, 70% is 70% of the world's production, and that is all in this very susceptible crop. Conversely, about 30% is the Robusta species, and this is actually the original genus of coffee bean. This is the actual first kind of coffee species, and actually the one that's actually quite hardy. It's also quite high in caffeine, so it might not give you the flavor hit, but it will definitely wake you up in the morning. And being that it's quite a hardy crop, it's actually quite amenable to being grown at sea level. So that's quite a good plus point for countries that are looking to develop and grow and cultivate this crop, that it can be grown relatively easy in kind of like climates that are readily found around the world. So when we think about the coffee itself, what it is a cherry. So we're going from fruit to bean in this step. We're talking that the cherry is picked, it has to be fermented down and given a bit of time to kind of rest and let the enzymes break down those kind of interesting chemicals and juices, and all of that migrates its way to the seed. And that's a lot of chemistry that's there. And between the various farms and the various countries that grow coffee, each process is widely unknown and not standardized. So we kind of understand that there is a natural process, there is a wash process, but the intricacies of how these are controlled vary from farm to farm, country to country, province to province. So just looking on the left, you can see that the coffee cherries have been picked and have been left on the table to dry out over the course of a day. The farmers are probably going out to fields, harvesting the beans and dumping them there for the day. And then they'll come back the next day and start processing them whilst they start to harvest the next batch of coffee beans. And on the right, you can see that the beans just have already been gone through a wash step, and they're now being dried in their parchment. So between the two of these, you tend to find that the natural coffee, so those that have been allowed to dry in the coffee beans, usually bring some more fruit and fermented flavors, because that bean has had more time to interact with the natural sugars from a cherry as enzymes break down that mucilage around the bean. Washed coffees on the other hand, are prized for their clarity and vibrant notes. So removing all of that cherry prior to drying allows the intrinsic flavors of the bean to shine through without anything holding them back. So you'll still find the kind of fruit notes and citrus notes, but really it's kind of got to pack that punch. But the point is, all coffee usually gets about a day to sit and dry out. How controlled this is varies from country to country, farm to farm. So there is great coffee, but there's no particular guide onto what can tell you what is a great coffee. My best advice is actually talk to your local coffee shop, talk to the experts and people who are working there, and actually get some insight to what is actually on offer. So there's no particular country preference. It could be Brazilian, it could be Sumatran, it could be Vietnamese. But it doesn't matter where your coffee comes from. It's understanding what flavors suit you, just like beer or wine or cheese or anything that you kind of tend to eat or taste. You are the master of your own coffee destiny. So I'm going to move on to the processing of coffee. So I'm going to talk about the roasting of coffee. So that's the thermal decomposition of these intricate chemical compounds that we've now got from our coffee bean. So this is a typical coffee roaster. It's 1 part tumble dryer to 1 part oven. And some use gas to heat the air. Others use some electric. You have better control that way. And unroasted beans contain similar, if not higher levels of acids, protein, sugar, and caffeine to those that have been roasted. So don't despair. What goes into the machine pretty much comes back out in terms of caffeine. But the primary kind of reason that we roast is because we want some compounds to degrade and actually decompose. In particular, we want chlorogenic acid compounds to break down. Now, chlorogenic acid compounds account for about 8% of the coffee bean. And deceptively enough, this compound doesn't actually contain any chlorine atoms, but the compound breaks down into a variety of like aldehydes, alcohols, carboxylic acids that your mouth and your body actually wants to take up. So this that you can see on the screen is a roast profile, and you can see that chlorogenic acid, which gives the bean that green color, slowly transitions to a kind of like light tan to a brown to a deeper brown, and slowly as you roast the living daylights out of it, it turns to a black and tends to elude a lot of oils and heavy acids. So what that means is this process requires a keen eye, or at least for the coffee roaster, a keen ear to be listening out to that oven. And just like a souffle, you don't want to be checking the oven door every now and then. You want to listen for your beans as they roast. And as they roast, there'll be a crack. And that crack indicates the kind of drying of the outer shell of that coffee bean. And if you hear a second crack in there, that usually denotes that that bean is done. So that's something that comes in about 8 minutes in. So the coffee roasters put a lot of time and effort to kind of like developing a roast profile and actually optimizing when it is to thermally degrade those compounds and get the best kind of like flavors out of that coffee. When it comes to flavors, we're thinking about what goes through. So that chlorogenic acid turns to those lactones, but we're looking at where these molecules fit within our flavor palette. So the Specialty Coffee Association of America have been working on this for a long time, and they've figured out over 800 to 1,200 individual aromatic chemical compounds identified in roasted coffee. So these have been polled by food scientists, mapped and published. But of course, the best thing to determine these flavors is you, the drinker, and your nose. They've handily taken this kind of dendrogram of kind of like all the chemical species and all the kind of flavors that come out of them and turn them into a very convenient kind of flavor wheel. So coffee roasters, and in particular cuppers, the coffee specialists, understand what flavors and notes they're supposed to be getting out of the coffee and the kind of roast profile that they perform. Another note on processing is actually taking your bean and then grinding it. So there's all sorts of different geometries of grinders that are out there. These are the two big ones that you can have: conical grinders or flat burr grinders. And there are debates about which are better. Even the cheaper ones with the little propeller that kind of goes around and spins very quickly and chops up the bean into very fine powders. They're available, but arguably the best result for grinding your coffee is the slow grinding mortar and pestle action of something like a conical burr grinder. And that's because it's grinding at a relatively low speed, around 500 to 900 revs per minute. And you want that low speed because you don't want to heat up your coffee as you're processing it. You don't want to lose all these complex chemical flavors and compounds as they're being developed. So that's what's unlocking that's what's the grinding process is doing. It's kind of unlocking those coffee flavors. Now, when you grind the bean, you're actually taking something that's quite small and chopping it into even small particulates. Now, scientists have a lot of kit and equipment to kind of map out these populations distributions and kind of spend a lot of time looking at the profile. So, mapping out, do finer burrs produce finer grinds? They want to look at the surface area to volume ratio of your grind, because if you have a higher volume to higher surface area to volume ratio, it means that you've got more surface area for water to get in, grab those fantastic flavor compounds and bring it all out. And that's really what you want to do in the process of making coffee. It's getting through that through the outer husk of the bean, actually pulling out those intricate chemical compounds. And I guess with all the analytical kit that's out there, this is probably the best that you're gonna. This is a photograph of a coffee ground, and as you can see, those little tiny pores and particulates, that's what the water's trying to get into. So we've got pores on the length scale of maybe tens of microns that water has to gush through very quickly, extract some very complex acids, aldehydes, lactones, and even some chlorogenic acid compounds, and bring them out. And it's a big ask to be doing that in the best course of 5 minutes. So here's another SEM micrograph of coffee grounds, and here's a fantastic colorized one provided by, I think it's Nescafe, but yes. But you can see these pores are quite small on the tens of microns kind of scale. So we're trying to force water into these tiny pores very quickly and pull out those flavor compounds. So it's a lot of work to be asking of the poor coffee bean. Finally, once we've done all the efforts of growing the bean and grinding it, we've got to store the bean and keep it somewhere safe. Now, ideally, we'd kind of keep it vacuum sealed, so away from oxygen and with the minimum amount of interaction until it's ready to be used. Now, my conscience as a polymer scientist does tell me that this is going to produce a lot of plastic waste. So I tend not to advocate just vacuum sealing the bag of coffee every time you come to use it. What you can do is use something convenient like a kiln jar, anything that has a very strong seal, and keep as much oxygen as you can out of your coffee. At a pinch, if you can't find a jar with a rubber seal, you can just store it in a tin. Be aware that the top layer of your coffee is probably going to oxidize and taste a bit dry or flavorless after time sitting there. But as long as you're using your coffee relatively quickly, I'm sure it won't make that much difference over the course of a week. However, the standard way that people are keeping coffee nowadays is in a Ziploc bag with a degassing valve to kind of push out any excess oxygen and allow you to kind of like maintain a good hermetic seal, a barrier between the outside environment and your coffee. I do like to note, please don't keep your coffee necessarily in the fridge. Some people, it's a very strong issue that they feel passionately about. Others kind of indifferent about where to keep the coffee in their house. But if that seal fails at any point, on the top plus side, your fridge will smell nicely aromatic and fragrant of coffee. However, your coffee beans are probably going to dry out and probably not going to taste the fullness of their flavor if you keep them in the fridge. Worse still, if you're constantly taking the coffee in and out of the fridge, you might even condense moisture in with your coffee, and that might give you a horrific moldy flavor when you come to brew it. So the next part of the talk, I'm going to focus a bit about the other important bit. So coffee we kind of know and understand and have a good handle on. But really, the water science has kind of taken a lot of people aback about how important water is for coffee. Now, water is it's quite a unique compound. I mean, for a coffee, it makes about 90% of the drink. For filter coffee in North America, it probably makes about 96 to 98% of the drink. And we've got to remember that water is a fantastic, from a chemistry point of view, it's a fantastic solvent. It acts as both an acid and a base. And even when it's sat there seeming quite innocuous, it's actually dissociating into H3O and hydroxide ions, so an OH ion. So it's actually quite fluid. It is actually forming acids and bases all the time, and that's at room temperature. Nothing else in it. No kind of external forces like working on it. That's what gives it pH 7. So 1 in 10 million molecules is constantly breaking apart from a neutral water molecule into both an acid and a base at the same time. So when we add coffee, it means we're actually relying on water to do a lot of work in terms of buffering, in terms of like mopping up excess acid, or even trying to kind of provide a bit more basic profile to itself to kind of like absorb that flavor, or kind of mop up that acid that it doesn't want. So thinking about geography and thinking about something that's been an important aspect of my life. Now, I know I live in Newcastle, and I've said I have a house and cats and a partner all here. But you might tell from my accent, I'm not a native of Newcastle. I actually grew up in a small town in the southeast called Epsom. And Epsom's famous for a few things. It's famous for the horse racing. So that's Tattenham Corner there. It's got a remarkable market town scene. That's a beautiful, extravagant clock tower that sits in the middle of town. It even had a PM came from the town. This is Lord Rosebery. So he was a famous politician in the 19th century that actually hailed from Epsom. Nowadays, however, things have changed. I'm afraid to say that this is the MP representing Epsom and Ewell, Mr. Chris Grayling. There he is, looking quite smug, off to deny some children their school dinners. I can't quite abide quite a nice photo of him there, so I'll go for one looking a bit more. I guess it's my natural cynicalness there coming through, but yeah, that's Chris Grayling. The face that face could launch 1,000 ships if only the ferry company actually knew that there was a ship to launch. And finally, I could talk all evening about Chris Grayling, but finally, Samuel Pepys. Now, Samuel Pepys was a diarist in the 17th century, and he lived at a very interesting time. And he started essentially the first kind of TripAdvisor blogs, telling people what was good, what was going on. He lived through the Great Plague. He lived through the Fire of London. And he even visited Epsom and said how fantastic the water was, how it was make you full of vim and vigor. And this is because Epsom sits on the North Chalk Downs. It's actually full of literally Epsom salts, and those salts are magnesium sulfate, hence the name for named after the town. Now, Pepys was a great advocate for the water and how great it was at the time. In the 21st century, all that calcium carbonate, the chalk, and the magnesium sulfate, which gets its way into the water table, does horrible things to your appliances. So this is the inside of a kettle in a typical home in Epsom. If you're unlucky to be the owner of a coffee establishment, this is probably what the inside of your coffee machine will look like. If you had a childhood like mine, it was filled with many cups of tea that looked like this, with a very interesting scum on top, that you just quaffed back and thought nothing of it, and thought that's what a cup of tea is supposed to be like, surely, and wonder why people come to your house and kind of like shudder away in terror. And finally, if you're making coffee with this kind of water, you actually get something that's quite flat and chalky, and it doesn't have a very good crema on top, and it actually looks like it does on the left half of the picture in the bottom right corner there. Conversely, you have a fantastic cup of coffee on the right, where you can see you've got a nice fully fledged crema, and it's obviously going to be full of bountiful flavors out of your coffee. And if you poll the UK and have a look at the mineral content of water, you'll find that the north of England does fantastic. You can see this, if you can see on the diagram, you've got this fantastic belt of blue, particularly Scotland. Everywhere north of the Tyne is doing great. Sorry, Gateshead. Is doing great for water, and you can see some fantastic coffee is going to be made there. Fanciful for whiskey in Scotland and Northern Ireland, but yeah, and you can see that divide, kind of like you're getting some good coffee in most of the north of England. On the east coast, you can see that you get down to kind of Hull. You can see that the water tends to get harder in mineral content and will contain more ions, and that will actually have a massive effect on the flavor of your coffee or anything you're going to cook with that particular water. Conversely, if you look across to Liverpool, you're going to get some fantastic coffee, maybe some medium amounts of coffee ions there, but it isn't until you get to Bristol that it really kind of gets hard on the west side of the country. And we've got to think, why is that the case? And unsurprisingly for the geoscientists, a lot of that is to do with the geological makeup of the UK. Where we get our water from is based on water tables and rivers around the area. So Merseyside obviously gets some fantastic water. Middlesbrough, thanks to Tees, everything around the Tyne, everything in the north of England can boast that it gets some fantastic water and fantastic flavors there. But of course, a lot of the London Basin and that Weald is going to draw from that chalky water. So we need to understand what kind of water, what kind of ions are actually going to affect the flavors in coffee. So there's three principal ions that we need to be concerned with. I know that there's going to be some potassium, sodium, and even some chloride in there, and even some sulfates, but doesn't matter so much. The big ones that we need to be concerned about are calcium. Like I've said, calcium carbonate is a big contributor to hard water. Magnesium, it's got a very high charge density and actually pulls and distorts molecules. And the final one, that's a bit of a outlier, is bicarbonate. It's a counter ion. It's a negatively charged ion. And the reason why we are quite interested in the amount of carbonate in water is because carbonate is actually quite a good buffer. Like natural water itself, it likes to buffer the amount of acids that are in the water. It likes to mediate. So we need to be aware of both the hard ion content from the alkali earth metals, but we also need to be aware of some of the softer counter ions that might be helping our coffees and balancing it out and providing some good flavors to shine through. So that said, now we have some understanding about water and how it actually affects the taste. We can actually think about some recipes for water. We can actually start with deionized water and actually play around with the salts and things that we can add to it to make it better, I would say better, but make it more flavorful. So we'd start with the kind of traditional XY of bicarbonate concentration versus the amount of hard ions that are in there. And actually, we find there's a very nice zone to work with, that within this zone, we get coffees that kind of allow their flavors to kind of shine and actually provide a good flavor of it. If you do go to Halfords and buy water and do have a sip of the stuff, I'm not advocating that you go to Halfords and buy a bottle of deionized water and quaff it back. But I'm saying that if you did start with purely deionized water, you'll find that the human body identifies it as being very flat, very empty, and even sour tasting. And it turns out the human body wants ions to be present. It actually detects flavorful water. Conversely, if you load it up with lots of ions, it becomes very heavy, it becomes very chalky, very flat, and kills all the other brilliant flavors that you're trying to bring out of your water. So when we think about recipes for water, we can actually mix up predetermined amounts of Epsom salts, of baking soda, and even gypsum salts, which are a good source of calcium sulfate, as well as the other two for sodium bicarbonate and magnesium sulfate. And we actually have some recipes for water. Instead of just making the recipes, though, we can actually examine the cities that we live in and actually the water content and see how that polls against great coffee tasting. So if we look at this diagram, we can see that the water of Washington, D.C., obviously a city of coffee drinkers, have actually got excellent water for drawing out some fantastic flavors in their coffee. The World of Coffee in Budapest have also got some fantastic water that will actually complement the flavors that they're trying to bring out. While some of the other cities may sit outside it, so we can see that Boston has very clean water, but might taste very flat and flavorless. Montreal, by the other hand, might actually be very chalky and quite have an excessive amount of ions in the water that actually bring out too much of what you don't want. So this kind of summary about water kind of shows how this innocuous substance, this thing that we take for granted, can have a massive influence on your coffee's flavor. Your water does need some salt and carbonate to make it taste and pop. But it's important to understand that locally roasted coffee is usually optimized for that coffee chemistry, for that local water that you're brewing with. So looking at this map on the right now, you can see that probably Scotland and Northern England has more in common in terms of water chemistry with Scandinavian countries, Brittany in France and Galicia in northwest Spain, than it does with London. So if you buy a bag of coffee from a local roaster here in the northeast of England, it's probably going to taste very good and exactly as it's intended. If you go to Norway or the great northern European plain, it's going to taste and have the same kind of flavors than if you literally went down the road to London and gifted it to someone and poured yourself another cup. One final point, I guess, to be made with all this talk about water is that large multinational corporations may ensure that their product is entirely on brand by using a totally pure water and disguising the taste of their coffee by adding other ingredients such as high fructose corn syrup or flavorings. A lot of hazelnut might be in there, sugar, lattes, that kind of stuff. So yes, I understand the appeal of a coffee shop bang in the middle of the city centre, but it doesn't necessarily mean that they make fantastic coffee. So my final point in this coffee talk that I like to kind of focus on is the extraction of coffee. And I know that we've touched upon it a bit, but I guess the traditional coffee that I'm talking about is an espresso. And the Specialty Coffee Association of America does define an espresso as 20 to 35 milliliters of beverage prepared from 7 to 9 grams of coffee, through which clean water of 92 to 95 degrees has been forced through at 9 to 10 atmospheres of pressure, and where the grind of the coffee is such that the brewing or flow time is approximately 20 to 30 seconds. Now, that's the definition of an espresso, according to the Specialty Coffee Association of America and all the rest of it. But when it comes to the coffee that I make at home, I might have a pour over filter. I might have a coffee siphon. I might not necessarily have the pressurized coffee machine that the SCA is actually trying to advocate that I use. And the only part of this that actually kind of is adhered to in a modern espresso is that 20 to 30 seconds bit. We kind of just bang out an espresso from the coffee machine. And that kind of changes our definition of what an espresso is. I mean, if you are fortunate to have, and I've been saving up for many years, but never quite got around to buying one, an espresso machine of yourself at home, you may find yourself bamboozled by all the accessories and gadgets and everything else. But these are the two big ones that you might find in the kit. And you might find that the basket on the left is a 20-gram basket. And the basket on the right is a piddly little 7-gram one. And when I want to make strong coffee for myself in the morning, I want the 20-gram basket. Now, this means that it doesn't quite meet the definitions of the SAA for the espresso, but I'm making a coffee that I want to drink. And a lot of people are drinking the same as I. A lot of people now favor the 20-gram basket. And when we look at the various ranges of drinks that are available, whether you want to go for a macchiato, whether you want to go for a cappuccino or a latte, you're mixing in more water, you're mixing in more milk. So you're actually distorting what is actually some coffee purists may say, the actual natural flavor of coffee. Now, I could spend a lot of time on this subject, argue what is a coffee, but I'm sure there's people out there saying, well, I like this kind of coffee. This is my kind of coffee. Your coffee is your coffee. Be happy with coffee. Just be happy that you're getting the best out of your coffee. Finally, I like to talk a bit about basket loading. So this is talking about the loading of coffee into that basket, and really to get the best out of your coffee, it's not so dependent about how much coffee you're using. What tends to be quite important is the actual ground size. So what I said before about chopping the bean into little parts, that actually has a massive effect about how waters can intrude into those pores and pull out those complex molecules out of the coffee and drop them into your cup. And we expect a good extraction yield of around 20%. So a lot of solid matter, a lot of those acids and compounds have got to come out of that coffee in a very short time. I mean, 20 to 30 seconds is not a long time for that kind of chemistry to happen. Now, this is kind of thrown in for completeness, but there is a lot of maths that's behind this. So understanding the fusion rates of water into coffee that kind of brings that back out. It's a lot of science that goes into that understanding, but we kind of boil it down to just, we'll get the best we can in 20 to 30 seconds. And that's a process that happens millions, if not billions of times a day around the world. So what it is with extraction, you're taking a very complex material, something like chlorogenic acid. It's been broken down by the roaster. It's been broken down into small pieces, and you're trying to get all these materials out of it. And do you understand that you're doing it at elevated temperatures? You're doing it at force pressures. And really, you want to strike that ideal balance between getting the best flavors out of your coffee without over brewing, without taking too much acids, a lot of the bitter compounds, a lot of that bitter material. So you want to actually strike that ideal balance of around 20% of that extractable yield. And that's a very hard target to kind of like land on. But hopefully understanding about the coffee science, hopefully understanding about the packing and grinding of coffee should give you some insight to why that is the case. So the result should be better coffee through chemistry. By understanding how you brew coffee, you should be able to get coffee that is repeatable every time and not variable. You don't want to be pulling kind of bitter acids. You don't want to be pulling mold compounds by storing it horribly in the fridge. So do use the right amount of coffee grounds in your machine, whatever that is, whether it's a V60 pour over filter, whether it's a cafetiere, French press, or whether that's something like an espresso machine that you've saved up long and hard and actually treated yourself, well, especially whilst you're living in lockdown. Do grind your coffee for a low amount of revs at a very short time. You can play around with the coffee chemistry. I don't advocate using bottled water in a coffee machine. I think that would be hugely wasteful, and I think that would be a huge disservice to the people who deliver our water. So thank you, Northumbria Water Group, if you're watching, for bringing us fantastic water that we can actually work with. And don't take too long extracting your coffee. Please don't pick up your phone and decide that you're actually going to say, right, I'm giving it 5 minutes. I'm brewing my coffee. I'm going to check out what's going on social media and pay attention to your coffee. It screams out attention. It wants you to actually, deliver the best for you. So having around 60 grams for every liter of coffee, for every liter of water out there. Understand, is it a coarse grind? Is it a medium grind, a fine grind? And figure out what's the best method to use. So use a French press if it's a very coarse grind, or use an AeroPress if it's a very fine grind. And the appropriate amount of time and guidance is on there on the side of the packets. Coffee suppliers want you to make great coffee with their product. So let's bring it back. So let's think about what coffee does for science. I talked a lot about what science does for coffee. This is what coffee does for science. So we, as a species, as people, we consume a lot of coffee. And I think I've already hit the hit the numbers when I said around 1.6% of the US GDP. Consumers spend about $72 billion on coffee. That's just in America. These are just figures that I can pull from America. So they spend $70 billion in coffee alone. And what are we going to do with all that coffee waste? So people are trying to make materials out of coffee. This is an example. These are tiles made from coffee grounds mixed in with plastic. People are trying to use coffee to filter. So we're going back again. We used to filter water through coffee. Now we're trying to filter water through coffee. And it turns out that all those pores and grounds, we can make foam. We can make foam composites, or we can make water fluidized water beds, and actually extract compounds like heavy metals and bind them in coffee. Understanding coffee chemistry and the science of this kind of packed media flow has been very important for things like DNA extraction kits. And I think what's really hit the news is COVID. So RNA extraction kits also rely on the understanding of mixing various buffer solutions, various salt solutions together, and understand what it is that they're going to extract. So we may think that coffee is quite a trivial thing, but it has a huge understanding it has a huge implication for the biosciences. And as a final point, I like to think that this does bring it full circle. So you can even use understanding coffee and coffee machines to do chemistry. So by taking a simple product like star anise, you can use a coffee machine, and researchers have spent their time in a lab somewhere. That I'd like to carry on this research if I could, but they're in a lab somewhere, and they've managed to use a standard coffee machine to extract a very important precursor to anti-cancer drugs. So this very functionalizable molecule, they've been actually able to extract using a standard coffee machine, and quite effectively at a commercial scale. So within 2 minutes, from grinding and loading from a 20-gram sample, they've managed to get a fantastic yield of a very important compound using a coffee machine. So I think that's a brilliant bit of science, and we should be thinking, what else can we use from nature to extract and kind of get the best out of? So how to make your coffee better? Probably start with ordering it from somewhere in the north of England, some people who own coffee shops, some baristas, some very skilled technicians who obviously know coffee and coffee science. Start with decent beans, so shop around, ask them what kind of coffee, where does it come from, the origins, if it's ethical or not. It's quite important to me when I'm sourcing coffee. Use the correct amount of grounds, so don't skimp on your coffee. Be bold and extract the best flavors that you can out of it. And try not to overbrew. Try not to overbrew. Try not to take as many of the compounds out of it. It's not a competition. Just get the best coffee that you can in those few minutes that you do. As a final point, I'd like to say support independent coffee shops. I know I work at the interface between academia and business. So I've been working closely with businesses in the Northeast, and it's good to speak to some people out there. So I'd like to have a quick shout out to Pink Lane Coffee in Newcastle, opposite the Littonville Society, and a couple in Middlesbrough that I've been fortunate to frequent in my time there, and many more coffee shops across the Northeast. They are diversifying their business models, so they've got online shops. They're offering gift vouchers and coffee subscriptions to let you taste some of the best coffees that they can offer. I'm sure now, as we're in the run-up to Christmas in just over a month, I'm sure there'll be advent calendars that can offer you fantastic flavors. And finally, if you are a business, please think about contacting a university. Maybe it's an interesting coffee-related project that we could do or work together on, and actually find some interesting science that can be done or brought out of your product. So finally, thank you again for listening to me. I know I've probably prattled on over the time limit, but I'm looking forward to some questions at the end. And if you do want to get in touch, my email is at the bottom of the page here, and I'm looking forward to fielding the Q&A. Thank you.
Thank you, Chris. That was great. I think we can all appreciate that you gave a very thorough grounding into the chemistry of coffee. If anyone has any coffee puns they would like to share, please do so now in the chat. In fact, you covered in so much detail the science there. I'm getting a little bit of anxiety that I might try and understand some of this before tomorrow morning's coffee, which I don't think is going to be possible, but we'll see. So we're going to take a 5-minute break now. If you do have any questions for Chris or any comments, then please do stick them into the chat and we will come back in 5 minutes for a question and answer session. Before we go to that, I will just let you know, if you want to know any more about Palace of Science, of course, you can visit our webpage. We have a YouTube channel. The talk this evening was recorded. Chris has very kindly allowed us to record it, and it will be uploaded to the Palace of Science YouTube channel in a couple of days. We also are on all social media as well. Our next event, we do have an event coming up. This was organised very last minute. We have a Sci quiz. So this is a Christmas and science quiz coming up next Tuesday evening at 7:30. This is going to be broadcast on Zoom. The idea being that hopefully if you want to tune in, then you can turn your camera on and we can see all of your lovely faces. I volunteered to host this quiz, and for some strange reason, I also volunteered to do the quiz while hosting it. So, I mean, it could go either way. But if you want to see how it goes, then next Tuesday for the Sci quiz. And of course, if you do have any feedback you would like to leave us, there is a feedback form. We will be picking a winner from the people that fill in the feedback to win some lottery tickets. I think that's everything for now. So we'll take a 5-minute break. Do enjoy this coffee-based quiz that I've put together, and we'll see you again in a little while. Hi everyone, welcome back. So I can see from the chat, or more specifically, I've been sent all the questions from the chat, curated by one of the Palace of Science members, that everyone's very interested in this talk. It's gone down really well, which is great. To be honest, in terms of my palate, I have the most unsophisticated palate. So all these coffee flavors you were talking about, as a scientist, I'm like, that makes sense. It all seems logical. But sort of the Yorkshire Neanderthal in me is going, fuck off. It just tastes like coffee. So in terms of the questions, I'm just going to leave it to the audience here, I think. So we'll jump straight in. So the first question that came through, would it be possible to grind non-roasted coffee beans, or is it just a matter of taste?
I guess you can work with non-roasted coffee beans, but really you're just going to extract a lot of chlorogenic acid. You're not going to get a lot of that complexity of flavor. So you're going to get a very literally green tasting kind of product. You're going to get a lot of that kind of. It'll probably be something like a matcha tea. It'll be very. It'll stop a lot of moisture from your mouth, and it probably won't taste that nice. So you really got to credit your roaster for doing a lot of hard work there and actually roasting the bean and actually degrading those compounds into more complex materials and flavors. So yeah, that's an interesting kind of thought. So not that I've tried it. Maybe I'll put that to some of the local roasters and see what they say.
They'll probably just shoot you down like, sacrilege.
No touching our stuff.
The next question, someone picking up on the fact that you mentioned the two major species of coffee. Is it just them two? Are there more? Is it to do with the flavour? Do all the rest taste awful?
I believe there's around 17 slightly different varieties of the coffee plant genus. But it really is down to those two. Those are the most prevalent, the most harvestable. There are subspecies. There are plants that have been crossbred, and some that have had something that's kind of crossed in their pollination line. That means that they yield. But farmers want to be consistent, and if you're a country that's known for growing a particular crop of coffee, you'll want to stick with it. So a lot of Central America grows Arabica beans, and a lot of that has weirdly the origins of coffee come from areas with traditionally quite high water scarcity. So Yemen and Ethiopia are thought to be the birthplace of the coffee plant. So they've traveled to around the world. They've traveled to Africa, and from Africa they've been grown. They've developed new flavors from the soils that are there. They've kind of like picked best plants, selectively bred the ones that they want out there, and then they've been transported to other countries. So there's one particular coffee species or rather coffee bean, the Panama geisha or gesha. Originally it's from Ethiopia. It's from a town called Gesha, and grown around there. And it migrated to Central America. I think it migrated to Panama. I think it migrated to another country, Costa Rica, before it made its way to Panama. And something specific about the Panama microclimate has really lent itself to some fantastic flavors in coffee. So yes, it's quite interesting how these species have kind of diversified and specialized. But around the world, yeah, I'm afraid for most of your bag, it's going to be Robusta or Arabica or a mix of the two.
Well, it's interesting that you mentioned the selective breeding there. So one of the things I thought, particularly considering how much money the coffee business makes, how important it is to so many areas, has there been any genetic modification for the species to really hone in on stuff like using less water in areas that are scarce, or increasing certain flavor elements, things like that?
I think we've got to. I'd love to throw this out. This would make a fantastic research project, and I don't know why Big Coffee's not getting behind it. But talk to the agritech team. That would be great. But
I'm sorry, it's my idea. That's patent pending.
Do you want to be the PI on this, Nicola? I think that I think as a commercial product, businesses don't want to diversify from what they know. So you've got a product, you don't want to mess with it. So you're growing areca beans. You have a workforce that is trained, that understands how to harvest these plants, how to work with these plants, what pesticides and herbicides to treat them with. So messing with your product, it's a very dangerous thing. It's a very it's quite a gamble for any kind of farmer, and this is a big cash crop for a lot of countries. So they're relying on this income to kind of keep them going. So there isn't an appetite for R&D and development from the coffee research kind of from the coffee growers end, and I guess from the market there isn't much need to diversify. I mean, you've got a product that sells. You got a fantastic market. Billions of people want this as their morning drink. So why change it? And I'm not saying that isn't a reason to start diversifying. I think, I've hinted, agri-tech spends a lot of money in research, and I think like bananas, like chocolate, these are crops that are at risk if they're not diversified. So having some different species into the mix may de-risk these potential cash crops and on all the land that is associated with growing them.
Yeah, certainly. There is a risk. Are there any coffee diseases that you know of that are likely to take down it sounds a bit like a Daily Mail headline that's going to come out like "Coffee no more in 2 months." Like
you'll also find on the Daily Mail like coffee disease cures cancer probably,
yeah.
And coffee rust. Coffee rust disease is probably the one that I believe. And I'm sure someone can correct me from the Newcastle Fungal Centre. It's a fungal-based pathogen, and that's it's a big thing that kills coffee plants and can decimate entire crops. I think it is partially related to potato blight. I don't know why a polymer chemist knows all these things, but yes, it's one of those jack of all trades things that you got to know.
I mean, I have to apologise to the audience there. I mean, we're in a pandemic. I didn't mean to bring up a disease that might wipe out coffee. Let's just forget that. It's fine. Let's move on.
Yeah.
You don't need that right now.
Coffee, bananas, toilet rolls. It's all fine. We're gonna get through this.
Someone's asking about the degassing valve. Well, just a clarification maybe. They thought it was mostly for carbon dioxide, not oxygen. Or is it not that complex?
I suppose you can let your coffee breathe. It is already dead. It is dead organic matter now. It's come off the plant. It's been harvested. It's been ground and put in a very clean Ziploc bag for the user. Yes, it'll push out carbon dioxide. I don't think you want carbon dioxide interacting with your coffee to kind of probably acidify it a bit more. But it's primarily for oxygen. You don't want oxygen in your coffee. That's definitely going to react with the coffee beans and coffee grounds that's in that bag. So if you do trap air in that bag, it's got a little degassing valve. Yeah, give it a squeeze, push that air out, and let it sit in the cupboard. So yeah.
There's been quite a lot of concern about that cup of tea that you pictured with the scum on top. Just outrage generally, but someone asking, is there some health effects there? I mean, generally, are you okay?
Am I okay? I ask myself the same question every day. I think there are no health effects. I mean, thanks Thames Water for doing the great work in keeping us alive and keeping it coming to my house, to everyone's houses. I think the water companies do a good job to make sure that there's no nasties in water. The biological pathogens are really the ones that really affect the water supply. But I think the ions in water that we drink are totally harmless. They're pretty benign. They even help the biology, and they're something that human beings actually thrive and need.
Yeah, just not when it's floating as scum on the top of your tea.
No, it did. I do have a particular soft spot for Yorkshire tea, and it bringing the bags home down to the southeast during semester breaks and making a cup of tea. I found the taste did change quite considerably.
I'm surprised they didn't stop you at the Yorkshire border, to be honest. I mean,
hand over your tea. Every time I go to London, hand your tea over.
So someone is talking about the water in Wigan. So where they live, it tastes fine from the tap, but when they boil it in the kettle for tea or coffee, it gives the drink a really chemical taste. So they use a water filter, but they're asking, is the boiling of it spoiling the water anyway, taking it out of its sort of natural state?
Boiling water won't remove any of the ions. Well, I say that it might attract those ions and condense them to the heater element at the bottom of the kettle. So it might remove some of those water ions if it is already quite soft water anyway. You might find that there could be something else happening with your water filter. So your water filter is probably doing a very good job in kind of substituting some of those ions, such as calcium or magnesium, for softer ones like sodium or potassium. So you'll find that water filters do help skim out some of the more aggressive ions in water, and that might be affecting your flavor. Where the chemical taste might be coming from, I don't know. I'm a little alarmed, to be honest, but I think it could be the drinker's own sensitivity, or it could be another factor of flavor. I don't think it's the water itself that's changing. I don't think that's anything that the kettle is doing that's actually affecting the water. So the water should taste pretty much the same before it's boiled and after it's boiled.
Okay.
Give or take some lime scale.
Someone asked, isn't a modern shot espresso double that millimeter measurement, so it's effectively a double shot? I think that's right.
Yes. I'm sure some barista somewhere is kind of rubbing their hands, and they've taken notes about some of the flaws about my coffee knowledge. But yes, the 20-gram basket, you'd pressurize your machine, you'd run water through it, and you would extract that entire shot as a double, or split it between 2 cups. It is more concentrated than you would expect, but I guess the point I was trying to make is that we're not dealing with pure coffee that we're used to. I think people's expectations of what they get from a coffee machine vary wildly. I mean, coffee shops themselves vary from what they serve from shop to shop. So a cappuccino in one shop might be a lot more bitter or harsher in flavor than a cappuccino in another coffee shop. So don't take it out on the machine. Maybe if you are a purist and you do want to use the correct size basket to make your espresso the way it should be, run with it. But yeah, don't let the SCA or the hands of the guild or whoever is puppeteering behind the scenes telling you how to make your coffee. You are the person who knows how to make best the drink that you enjoy.
There's quite a few questions coming through about decaf coffee, whether it tastes massively different, and how is it produced?
I guess this lends itself to a lot of interesting chemistry, and I think that I can't say for certain. I'm sure Mr. Nescafe or Mr. Illy, whoever's out there manufacturing coffees, got very stringent IP and confidential information about how they make their coffee. But I believe that they use an extraction method, quite possibly using supercritical carbon dioxide. So that's carbon dioxide that's pressured to around 70 atmospheres, around 78 degrees C. And they'll push this coffee they push this solvent now through coffee and extract the compounds that they want. So for caffeine, which I'm trying to visually picture the molecule and trying to draw it out for some of the viewers, but caffeine is quite a polar molecule. It's got some components that actually quite like being dragged about by a solvent, and I think that kind of symmetry and that kind of polarity of the solvent means that if you've trying to use a solvent gradient, or you're trying to use chromatography to extract such a small molecule like caffeine, means that you can separate it off out of the bean without disturbing a lot of the other chlorogenic acid compounds like malic acid or I want to say like not phenol. There's no phenol in coffee, but chlorogenic acid and related lactones that kind of like have been degraded by the Maillard reaction in roasting. So it is going to be an extraction process. There is going to be a chromatography gradient in there. The solvent that they're going to use is going to be quite inert. So that's why I suggest that it's going to be something like supercritical carbon dioxide, and it's going to be a lot of intense knowledge that's put behind it. But of course, they're not going to tell us. It's a big secret that they're keeping on the wrap. So I'm sure that there are ways and means, and I can only hazard a guess. But yeah, that's how I think companies make decaffeinated coffee.
I love the term supercritical carbon dioxide. Never has a good word to say.
Nice, flowy, lots of syllables. It's
someone's saying, I live in a hard water area and I have a water softener that's plumbed in, an ion exchange type. Should I be adding anything to my softened water for the best flavour?
I suppose you could call up the chemical analysis laboratory. They will do a lot of work to, if you've got the money, you can pay them and they'll do a lot of work. They'll do some atomic absorption spectroscopy and look for the ions. So they'll look for what metals are actually in your water, and then they'll do some more work, some bits of glassware, and do titrations, all that stuff we learned at A-level chemistry. They'll do some titrations, actually find what kind of counter ions are floating about in your water. But to be honest, I think if you live in a hard water area, you've got an ion exchange membrane, or you're running a reverse osmosis filter, you're probably stripping away a lot of those hard ions out of there. Putting them back in, it's always going to be a gamble. But there's a reason why you have a hard water filter, so it doesn't ruin your washing machine, or it doesn't ruin your kettle, your immersion water heater, or your shower. So you probably have all that kit in place, so you can possibly assume that you have deionized water coming from your filter, and try playing around with small quantities of Epsom salts or baking soda and see if that kind of like tweaks the flavor of your coffee. But there's so many different parameters. I mean, water's a very important aspect that just naturally comes out of your tap. So be thankful for those companies that supply it at a reasonable rate, may I say.
Yeah, a bit of seasoning, OXO cube, Bovril perhaps. That's what I'd recommend.
Just bring out the flavor, yeah. Bovril's a good one especially for the Northwest. Get the Bovril
in. So you've covered a lot about coffee before it gets into the cup, but what happens afterwards? Does our perception of flavour change with the temperature at which we drink the coffee?
I haven't thought about it. I guess it'll be good to get some more thoughts and opinions from behavioral psychology. I mean, does my fifth cup of coffee taste better than my first? I'm not too sure. Is it because it's colder? Should I microwave it? Never microwave your coffee.
But why?
not as a researcher, I have ever microwaved a tea or coffee in my life. But I think that there is going to be an association that you are going to have some effects from temperature, certainly for extraction. So you're going to find faster rate kinetics. You're going to find that smaller molecules travel faster. You're going to find larger molecules will be more mobile in a faster solution. I think the best example that I can think off the top of my head of this is a phenomenon that's come up over the past decade, where coffee shops are starting to specialize in cold brew coffee. Now, I was going to say in summer 2019, when we can actually go to coffee shops and actually experience this firsthand, you might have seen that some coffee shops have started cold brew coffee, and you get a lot of flavor out of that coffee, but with a lot less nicotine, a lot less caffeine. That'd be scary. You get a lot less caffeine extracted through using the cold brew method, but you still retain a lot of the more mobile chlorogenic acid compounds, a lot of those carboxylic acids, lactones, and kind of like organic notes coming through. So you probably affect the kinetics and that extraction process by maybe not heating the water up as hot. Certainly when you pour it out of the kettle, you might be boiling the kettle, but it is never at 100 degrees C, unless you can collect the steam that's not 100 degrees C. That's why an espresso machine is actually steam extracting those organic compounds out of there and actually bringing those flavors out there in a very short amount of time. So 20 to 30 seconds isn't a lot of time to do a lot of very interesting chemistry. So yeah, when your flavor profile is going to vary, I think try it out. See if your coffee, the same coffee, tastes, through an espresso machine at temperature, high pressure and high temperature, compared to a V60 pour over filter or a cafetiere. You're going to get slightly different extraction profiles from both of them. And yes, I'd love. Why isn't Big Coffee sponsoring us for a fantastic coffee project? Yeah, it's always very interesting. I guess person to person, taste to taste, the temperature is going to make a slight bit of difference, but not by the time you've had your fifth cup.
I mean, if anyone else's office is anything like where I work, these experiments are already going on, all these different types of coffee making, temperatures, timings, everything. It's happening. Procrastination, another real added benefit of coffee drinking.
It does, yeah. A lot of pausing and thinking. It's not as harsh as the tea debate, whether to put the milk in before or after. But I'll save that for another researcher to take over.
A geographical question next. Someone asking, do you know why Portuguese coffee is so smooth? They always get great coffee in Portugal. Generally supposed to be something about the roasting step, but I don't know if you know anything Portuguese specific.
I know nothing about Portuguese coffee. Send me Portuguese coffee. We'll find out. We'll have a live experiment.
We will do that research.
We will do that research. We'll take that one for the team. Please send us all that Portuguese coffee just to Newcastle and we'll assess it. And the research teams will assess it. Yes, I'd like to know if it's something to do with the grind or something to do with the processing. I know that some Spanish coffees away, very clever housemate, he told me that some of the Spanish coffees, the way they were shipped from the countries where they're grown, particularly in South and Central America, the way they were grown and sent back to Spain, they would do or employ some very interesting kind of preservative methods. So whether that's part of that process or whether it's something about specifically Portuguese brewed and ground coffee, I couldn't tell you. But yes, I'm very curious to find out myself.
Another aspect that I'd happily research as well. So pizza dough quality is famously affected by water quality. Do you have any thoughts on this? Do you know anything about pizza dough quality?
I think we're covering in quite a broad spectrum of kind of like topics and knowledge here. I think
you started this.
I know. Why did I go with the chemistry of coffee? I think pizza dough and the water that's used for making pizza dough, it will be affected. You're going to find again those ions are going to do weird things to coffee. Certainly down in Epsom, washing my hair definitely took a hit for the team. Soaps don't foam or lather as they're supposed to if you've got a high concentration of mineral content. So yeah, washing this was hell in Epsom. It was something that would really affect it, as well as killing all your appliances, killing your kettles, your washing machine. So it doesn't surprise me in the slightest that people trying to cook with it and do things with the water are going to find that it affects them in different ways. So even bathing in it, swimming pools, they'll want some mineral content in the water to stop it kind of clagging, because water, if it's totally bereft of ions, it's going to feel kind of slick and slippy and have quite a meniscus. It kind of rises quite well if it's fully deionized of water, had all its ions removed, totally deionized. So yeah, having some ions in the water is going to be great in terms of actually being to handle it and have something that actually feels like water. But obviously too much of it is going to do horrible things to the things. I think probably with pizza dough, it's going to be like the starch molecules of the flour. It's going to be some of the gluten that's in there, and I'm only hesitating to guess. I'm not up on my pizza chemistry. We'll let someone else fill this talk as well. But yeah, I think the water is going to have quite an interesting effect on how that is going to affect the stickiness and the bounce of their dough. So yeah, doesn't surprise me, and please experiment and send those pizzas our way.
Yeah, check the water before eating your pizza in the swimming pool is what I understand from that. Yeah,
and make a few more just to be sure.
So if we're getting this right, the smaller the coffee grind, the more flavour you can extract when the water is passing through.
Correct.
Correct.
I would say you're probably extracting more everything. So more flavor, more of those flavors that you want, and quite possibly more of the flavors that you don't want. So probably some of that starting chlorogenic acid compound, some of the larger complex kind of molecules. So you probably don't want to be passing more water and extracting those heavy claggy ions molecules and bringing them into your coffee. Conversely, you could miss out a whole lot of interesting molecules. So you can miss out some complex lactones, some interesting phenolics, some nice floral scents and flavors. And again, like the SCA, the powers that be, they've mapped it all out, and they know what Big Coffee has spent its money on analysis, but it's not sharing it willingly with everyone. So we do know what's published out there. We do know that there's a lot of information in those journals of food science and kind of what compounds are out there, and especially what the human body tastes. So traditionally, the human body is quite attuned to things that are going to kill it. So things that are bitter, things that are poisons, potential poisons, the human body kind of latches onto and flags up as something that they want to find out more about. So our body's very keen on those acids and compounds, and yeah, we'll want to extract those without extracting some of the heavier, bitterer kind of flavors in there.
Unless it's your personal preference, of course, in which case go wild.
Yes. I know that the coffee industry, and particularly those that work on freeze-dried coffee, the instant coffee, the most hated of all coffees, I guess, but also the most convenient, especially in the morning when you just want to make something that's warm and tastes vaguely coffee-like. Those companies are very good at extraction. They probably extract about 60% of all the compounds that is in the bean, and that's very efficient. Kind of gathering and molecule gathering, and they do chop and change the bits that they want so that you can taste, and but it's some very clever science to actually make that instant coffee, and they know what flavor profile to really dial in. So yeah, there's a lot more to it than meets the eye, I guess.
There's someone asking about the addition of milk to your coffee. So how chemically different is a dairy alternative to traditional cow's milk? Would it affect how we brew coffee?
Certainly milk is not going to affect the brewing process in itself, because you kind of I assume, or I take the question, I assume that their starting point is the espresso. But when they use a milk alternative, or they use compared to milk is a very interesting substance in itself. It's mostly water again, and fats, and kind of unpleasant if you think of it in those terms. But it's interesting how sugars, some sugars, it's helps a stout, and helps soften a kind of particularly harsh stout, if you like. But yeah, if you add milk to your coffee, and you compare it to a coffee with a milk alternative, I guess it's going to lack a lot of those compounds. It's not going to have the same kind of fats, which is quite possibly a good thing if these are cis fats in your coffee, and you actually want kind of healthier trans fats in there. So you want to focus on having a milk alternative where again it's processed, it's had someone kind of like monitor the output, and so they want a very consistent number of solids. They want a very consistent number of proteins, sugars in that material, as opposed to milk, which is standardized to an extent, but could have a lot more fats in there, which can bind to those coffee molecules, bind to those acids, and suppress all of those interesting flavors that you're trying to bring out in your coffee.
We have a message from Josh from Off the Ground.
Fantastic.
Really liked your talk and the mention. He's wondering if you come across any good research or had any experiments with brew pressure for espresso and come up with any conclusions.
I would like to say just general chemical engineering knowledge. You'll want to not over pressurize your machine for the best extraction. But I think there was a paper earlier on this year in 2020, I think it's in Soft Matter Physics, that actually talks about reducing the amount of mass or coffee mass to actually perform an espresso extraction with a machine. And by lightening that mass, you can perhaps drop the pressure, and that will improve the efficiency of your coffee extraction. For Josh, out off the ground, that's quite significant, because you'd probably be able to save some of the capital costs that you're actually working with. So you can save some coffee bean and get the same flavor profile back out. So I guess you can kind of tweak the optimum kind of pressures, but really try and play around with the mass and kind of flow times a bit more for the best extraction. I guess that's some advice for Josh. And yes, I'd like to follow up later on, and we'll try and get some collaboration and optimize your coffee extraction.
Yeah, he certainly says any experimenting you'd like to do, we're all ears. So perfect.
I guess a field trip and some working off-site down in Middlesbrough is required post-lockdown.
This is an interesting question. What would you need to change to make the perfect coffee on the International Space Station?
That is an interesting question. I don't know enough about coffee brewing in space. I'd love to go to space one day. I think a lot of scientists kind of aspire to that golden goal, but I don't know what it is specifically about trying to brew in space that's difficult, and what it is about extraction that's so hard. So I guess with a traditional machine, we're relying on a pressurized jet and a bit of gravity to do the work of the extraction. I guess zero gravity is going to play with how you pack your bed. I suppose you have to put some energy and effort to actually force your coffee grounds into the basket and to make a very fine puck of coffee. I guess you're going to have to worry about your steam pressure. I think this comes back to Josh again. I guess you have to worry about your steam pressure, and you want a directed jet of coffee to find that mean path to extract the water, extract all the best coffee compounds through the coffee. And finally, when it drops through on the other side, I guess you do want some sort of containerized bag that it's going to suck in or inflate and capture the coffee, because I don't think espresso floating around the space station is going to be very good for anyone's day. So
yeah,
I think there's a lot of challenges there.
Additionally, there is the problem that on the International Space Station, taste is not as strong. I don't think we know exactly why, but I know a lot of the food they send up there, they add extra. So for salt, they add much more salt or spice. They add a lot of spices to things just to try and get some flavour, because I think taste is generally sort of dampened up there, but we're not sure why.
I do know that they do say that airline food and food on aircraft, because they're operating in a reduced pressure environment, and the air tends to be drier as well. This could be another factor in the taste. So we're more concerned about the environment again. So this is thinking about the water. We're now thinking about the moisture in the air. So and we do a lot of our tasting not with our tongues, but more with our nose. That's the kind of scent sensor for all our tastes. So food on aircraft and those kind of environments, they do add more salt. They try and bring out more of the umami flavor, which seems to be lost in a pressurized cabin environment. So I guess for astronauts, they'll try to redress the balance by maybe moisturizing their noses, if that's a thing that can be done. So maybe get the little sucker thing and kind of squirt your nose with water before you kind of like get a flavorful of coffee, and kind of make sure that you have a good environment for sampling your drink in. So I guess that's not to dry an atmosphere that they're working with. But obviously on the International Space Station, they're very limited in what they control. So I'm afraid they're going to have to sacrifice great coffee for working in space, which is pretty awesome.
Yeah.
Small differences, like trade coffee, space.
Do you know anything about the safe amount of caffeine that you can consume daily, and whether humans build up a tolerance to it?
I believe that there have studies been done by colleagues in Northumbria University, and I don't think there's a recommended daily allowance of caffeine. What I suppose the upper dosage limit, I guess, for coffee is still quite an unknown, but I know that guidelines are out there because of the high blood pressure effects that kind of arise from giving people caffeine. Any kind of stimulant is going to have a kind of guideline amount of what they can give. I honestly don't know.
I would imagine you do build up some form of tolerance, just based on it is a drug. But
yeah, the body
I
should
don't know
develop
to what extent.
A body should develop the enzymes to kind of process those chemicals and kind of learn to accept that I'm going to get a hit of this at 7:15 in the morning. I'm going to have to generate something to kind of process it, or the liver gets used to seeing it in its system, and the liver is a very resilient organ to kind of deal with these things. So yes, I expect that there will be some kind of tolerance, but I'm going to have to do some digging and research on that one and see if there's see what the literature says. And of course, physiologically, this is going to vary from person to person, their background, their history, and what their kind of drug absorbance is kind of like. So imagine a small child giving them a liter of cafetiere coffee is probably not going to do them any favors. But for your veteran researcher who's used to this after decades of caffeine abuse, is probably going to be quite fine sucking back a whole cafetiere of coffee at 8 in the morning.
Yeah, so you will have missed it, but one of the questions I included in the quiz was about caffeine limits for Olympians, and I think it works out about 5 cups of coffee. If you go over that, then you're over the caffeine limit to compete in the Olympics, which I didn't know.
That is interesting. Maybe it's going to stimulate them further. Maybe it triggers something in the drug tests. I don't know, but that's every day's a school day. I think so.
Someone's mentioned here a really cool idea. Does anyone make a coffee machine with sensors that analyze the water, or have a GPS location capability and adjust the preparation accordingly?
That is interesting. I'd love it if there was. It'd be a fantastic bit of kit if it was out there. I'm guessing
expensive, but
it'd be quite expensive. Someone out there, some multi-billionaires, probably rubbing their hands, going, "Oh yeah, the perfect cup of coffee every time." I guess the closest we're going to get to that is just knowing what the water quality is like in the city you live in. That's kind of relying on people like Northumbria Water Group or Thames Water or wherever you live. Their water diligence in monitoring and tracking what is actually going out there in the pipes, and then when it gets to your tap. I guess you would need to kind of have a atomic absorption spectrometer tacked onto the back of your coffee machine. Now, these things tend to take up a very large table in a laboratory. So the likelihood of them making it into most kitchens is pretty unlikely. And again, for the counter iron, so looking for sulfates, looking for carbonates in water. I'd love to say if it was the same test, but it's going to be an entirely different test setup. So it's going to be some sort of auto titration setup, which is, again, it's going to take up a large sizable. One of these machines takes up a large portion of a lab. To have it in the kitchen would be fantastic. How portable this machine is going to be, I don't know, but yeah, we'll work on living the dream and hopefully have that everywhere, every time the perfect coffee machine is going to be made.
Someone here, I presume, that knows you, asking, can we do the chemistry of chili next time? Remember when you ate that California Reaper in the canteen? Care to elaborate?
Oh God, yeah. I guess the yes, I guess the Carolina Reaper is a particularly nasty kind of pepper, and the measurement for measuring the hotness of chilies is measured in Scovilles, and that's the number of liters required to kind of nullify the flavor. The California Reaper hits it at pure capsaicin is around 15 million, and the California Reaper hits around the 7 million mark. So that's 7 million liters of water to actually null the taste and flavor of the chili. So I downed pretty much a gallon of milk in that time, and that was enough fats and acids that kind of neutralize that flavor. But yeah, I think again, another researcher to take the to take the mantle of the science of chili, or the chemistry of capsaicin, will be one for another talk.
Birds can't taste it. That's as much as I know. Birds will eat as many chilies as you will feed them. Okay, so I'm going to end on this last question. Very important. Where is the best cup of coffee you've tasted, and what is the best snack accompaniment?
See, this should be. I was gonna say it could be very easy or it could be a very difficult question. The best cup of coffee I taste or have ever tasted is every day at around 7:30 in the morning when I get up and I'm feeling a little blurry and I decide to make my way downstairs and make myself and my partner a cup of coffee. And that is the best cup of coffee I've tasted. The best snack accompaniment for that coffee, say, is breakfast. Anything to line the stomach. But really, it's good company. And that's all I can really say to
that. Stop it. Well, thank you so much. That was really enlightening. A lot about coffee I didn't know. And I'm sure I will think a lot about this tomorrow morning before my cup of coffee. It's probably not, actually. It'll be way too early. But thank you. And of course, thank you to the audience for tuning in. I hope you enjoyed that. If you do have any feedback, then please do let us know. Thank you for all the questions and the engagement. That is the last CyberSciBar of 2020. We'll be back next year with an incredible set of speakers. If you want to find out who's speaking, you can't yet because I haven't booked them, but I will. But as soon as I do, they'll be up on all of our social media pages and our website as well. So please do stay tuned in for that. We have one more event coming up. Next Tuesday, the 1st of December, we have a Sci quiz. So this is a Christmas and science quiz. If you think you can beat me at a science quiz, then that is your chance. It'll be on Zoom. Free to attend. There will be some prizes to be won as well, so please do tune in. And thank you again. See you next Tuesday, and if not, then probably see you next year.